Welcome to the Deep Dive, the place where we sift through the sources you share, pull out the key info, and really try to break down complex stuff into conversations that, well, hopefully stick with you.
And today we're shifting gears a bit. We're moving away from, say, big societal trends and diving deep into the natural world. We're looking at a true evolutionary success story, one that honestly puts most other creatures to shame.
Yeah, this deep dive is all about the dragonfly life cycle. We've got some great listener-provided sources here, and they feel pretty academic, almost like a field guide or an entomology lecture.
That's a good way to put it. Comprehensive. Our job then is to unpack all that detail and understand how this creature has managed to thrive for, well, for almost unbelievable amount of time.
We want to get past just seeing that beautiful darting insect in the summer, right? We're aiming to peel back the layers on its three really quite different life stages. How does this cycle make them so successful?
Exactly. And the sources laid out clearly. Egg, nymph, and adult. Three distinct phases.
Okay, but before we jump into stage one, we have to hit that headline fact, the one that just jumps off the page. The sheer age of these things.
Right. That's the real hook here. When we talk about ancient life, dragonflies are in a league of their own. They've been around for more than 300 million years.
300 million.
I mean,
It's almost impossible to wrap your head around. We're talking, what, the late Carboniferous period?
hey, precisely. Way before the dinosaurs even showed up properly. Back then, land life was mostly giant insects, early reptiles. A very different world. Higher oxygen levels, too, which might explain some of the giant insects back then, including early dragonfly relatives.
And yet, something fundamentally like the dragonflies we see today was already flying around, already working through this life cycle.
It's staggering, isn't it? Think about everything Earth has gone through since then. Mass extinctions, ice ages, continents crashing together.
5 major extinction events, the sources mention.
5. And through it all, the dragonfly's basic design, its life strategy, it just worked. It persisted. That's why they're often called living fossils. Their blueprint is ancient and incredibly effective.
So, studying their life cycle is like looking at a masterclass in survival, honed over hundreds of millions of years. This three-stage process must be incredibly robust.
It really seems to be. Each stage is super specialized for its environment, its purpose, different biology, different challenges.
Okay, let's get into it then. Stage one, right at the beginning. The resilient egg. Where does the journey start?
It starts right after the adults mate. The female has one crucial task: get those eggs into or near water. Because the next stage, the nymph, is completely aquatic, can't survive out of water.
And it's not just a matter of, dropping them anywhere. The sources point out there are different methods.
Yeah, quite varied actually. Some species are very careful. They have this specialized structure, an ovipositor.
Like a little needle or blade?
Sort of, yeah. And they use it to insert the eggs right into plant stems below the waterline, or sometimes into mud, or even rotting wood.
Okay, so that sounds like a strategy for protection, right? Hiding them away.
Definitely. Protection from being washed away by currents, protection from drying out if the water level drops a bit, and importantly, protection from predators like fish that might just gobble up eggs floating around.
Makes sense. But then there are others that just drop them.
That's the other main strategy. Some species just fly over the water and basically dip their abdomen in, releasing the eggs directly into the water, sometimes in strings, sometimes individually.
So for those ones, the egg itself must be pretty tough to survive just floating or sinking.
And that's the surprising part. We tend to think of insect eggs as, well, delicate. But the sources emphasize these are tough eggs. Flexible, too.
Tough and flexible. How does that work?
They have this outer layer, the chorion, which isn't brittle like, say, a bird's eggshell. It's got some give. This means they can handle physical stress better.
Like what kind of stress?
Two big ones mentioned are rapid temperature changes. Think a cold snap hitting a pond and strong water currents, like after heavy rain. A brittle egg might just shatter or get damaged. These can apparently roll with it, literally sometimes.
Okay, that makes sense for surviving the immediate environment, but the really mind-blowing part, for me anyway, was the dormancy thing.
Ah, yes. Diapause. That's the scientific term. The sources highlight that some eggs remain dormant through the winter.
So they just wait.
Pretty much.
Mm-hmm.
It's not just like being asleep. It's a specific physiological state where development is arrested, paused. It's controlled by hormones, often triggered by changing day length or temperature cues in the autumn.
And they wait until?
Until conditions are right again. Usually the warmth of spring, maybe specific water conditions. Then development kicks back in, and they hatch. It means they don't hatch out in the middle of winter when there's no food and it's freezing.
That's incredible flexibility. Hatch quickly if it's warm, or just hang out dormant for months if it's not.
Exactly. It's a massive survival advantage. Think about unpredictable weather, droughts, harsh winters. This dormancy drastically increases the chance that the next generation will survive. It hedges their bets against bad conditions, ensures continuity.
So even at the very first stage, this tiny egg is already a master of survival. Okay, that sets the stage perfectly for what comes next, the phase where they spend most of their time.
Right. From that resilient little package, we move into the underwater world. Stage 2, the submerged predator, the nymph.
And this is the key thing to grasp, isn't it? When we picture a dragonfly, we see the flying adult. But that's just a fraction of its life.
A tiny fraction, usually. The sources stress this. Dragonflies spend most of their lives as nymphs underwater. Forget weeks or months, we're talking years for many species.
Years, okay. And their development is different too, not like a butterfly going into a chrysalis.
No, completely different process. Butterflies have complete metamorphosis. Egg, larva, pupa, adult. Dragonflies undergo incomplete metamorphosis. Egg, nymph, adult. They do not have a pupal stage.
So the nymph just gets bigger and bigger.
Essentially, yes. They hatch looking vaguely like wingless underwater dragonflies, and then they grow by shedding their skin molting multiple times. Each stage between molts is called an instar. And with each molt, they get bigger, and wing buds might start to develop externally.
But they stay active hunters the whole time.
Absolutely. They don't hide away to transform. They're active predators right from the start, just getting larger and more capable with each molt.
Okay, back to the duration. You said years. How long are we talking?
It varies a lot by species and climate.
Yeah.
In warmer places, maybe just a few months. But in cooler, temperate regions, the sources state it can be up to 5 years.
5 years. Living underwater. Waiting. Growing.
5 years. Compare that to the adult stage, which might only last a few weeks or maybe a couple of months. It completely reframes where the bulk of the dragonfly's existence actually happens.
So that 5-year investment, it's all building towards that brief adult phase.
That's the evolutionary logic, yes. All that time is spent growing, developing the complex musculature needed for flight, storing energy, basically building the perfect adult machine for its final short mission.
And what are they doing down there for 5 years? Just hiding?
Oh, definitely not just hiding. They are serious predators. The sources describe them as powerful predators in their freshwater ecosystems, little apex hunters of the pond bottom.
Right, and they have that crazy jaw thing?
The labium. Yes, it's truly unique. It's basically their lower lip, but it's highly modified into this extendable hinged arm folded under their head.
And it just shoots out.
Exactly, like a spring-loaded trap. When prey comes within range, the labium shoots out like a spring-loaded arm with incredible speed, faster than most prey can react.
How fast are we talking?
Milliseconds. It's incredibly rapid. There's some debate if it's purely muscular or uses hydraulic pressure hemolymph their blood, but either way, it's lightning fast. And at the end, it has hooks or teeth to grab the victim.
Wow. And what are they grabbing with this thing?
A whole range of things. The sources list crucial prey, like mosquito larvae.
Ah, so they're helping us out even then.
Definitely. Major natural pest control happening underwater. But they don't stop there. They'll take tadpoles, other aquatic insects, worms, even, surprisingly, tiny fish.
Tiny fish. A little nymph can take down a fish.
If the fish is small enough, absolutely. They're quite voracious. This makes them really important in the food web. They're controlling populations of smaller organisms.
So for 5 years, they're not just waiting. They're actively shaping the ecosystem of that pond or stream.
Precisely. They help control other populations, especially potential pests like mosquitoes. And their long lifespan means they provide this ecological service consistently, year after year, before they even think about leaving the water. They're a stabilizing force down there.
And they have to breathe underwater all that time too, right? No lungs yet?
Correct. They have gills, but not like fish gills on the outside usually. Many species have internal gills inside their rectum. They pump water in and out of their back end to get oxygen.
Okay, that's slightly less glamorous than the extendable jaw.
Maybe, but it's effective. And some nymphs can even use that pumping action for jet propulsion to escape predators quickly.
Clever. And they must be well camouflaged too, hiding for years.
Oh, yes. They're often muddy brown or green, blending in perfectly with the sediment, decaying leaves, or underwater plants. Often they'll let algae grow on them too, enhancing the disguise. They are masters of the sit-and-wait ambush.
So all this time, maybe 8 to 15 molts getting bigger, stronger, storing energy, all leading up to the big finale.
Exactly. That huge investment of time and energy honed over years as an underwater killer is about to pay off in a radical transformation.
Okay, this is where it gets really interesting for me, that transition. After years hidden away, this final step into the air seems incredibly risky, but also fast.
It is fast and incredibly risky, probably the most dangerous few hours of its entire life. This is stage 3, the master of flight, the adult.
So how does it start? It just decides one day, okay, time to go.
It's triggered by internal development cues and likely environmental signals too, like water temperature and day length. When it's ready, the nymph makes its move. It climbs out of the water, usually at dawn.
Dawn. Why dawn?
Good question. The sources suggest it's about minimizing risk. Fewer bird predators are active right at dawn. The air is often more humid, which might help prevent the nymph from drying out too quickly during the emergence. And the gradually rising sun provides warmth needed for the process.
Okay, so it crawls out onto what?
A plant stem, a reed, a rock near the water's edge. Somewhere vertical, usually. It needs to anchor itself securely. Then the really dramatic part begins.
The escape.
Exactly. The exoskeleton along its back splits open.
Yeah.
And slowly, painstakingly, the adult dragonfly starts to pull itself out of its old mink skin, the exuvia.
That must be exhausting.
It looks exhausting. The newly emerged adult, sometimes called a tendril, is incredibly soft, pale, almost ghostly. Its wings are crumpled, wet, and useless at this point. It's completely vulnerable.
So the wings are the crucial next step.
Absolutely critical. It has to pump fluid hemolymph into the network of veins in the wings. This hydraulic pressure forces the wings to expand, flatten out, and take their final shape.
And this has to happen quickly.
Yes, within a few hours. The wings need to expand and harden before they dry out in the wrong shape, or before a predator spots this helpless creature. If the wings don't form perfectly, it can't fly. And if it can't fly...
Game over. No reproduction.
Exactly. The entire multi-year nymph stage would be wasted. But assuming it works, once those 4 wings are dry and rigid, the dragonfly is ready. And what emerges is, as the sources put it, an amazing flyer.
Amazing doesn't quite cover it, does it? The flight capabilities are just stunning.
Truly top tier in the insect world. They list the specifics. The ability to hover perfectly still, like a helicopter. They can fly straight up, straight down, even fly backward.
Backward. Not many things can do that well.
Very few insects manage it effectively. And they can dart sideways instantly and change direction on a dime, often without losing speed. They have incredible agility.
How do they do that? Is it the 4 wings?
That's the key. Unlike insects, where wings are often coupled, dragonflies can control their front and hind wings independently. They can flap them out of phase, change the angle of attack constantly. This generates complex aerodynamics that allow for that extreme maneuverability.
And all that fancy flying isn't just for show, right? It's about hunting.
Directly linked. Their flight mastery makes them incredible hunters in the air. They are aerial predators of the highest order.
And there's that statistic, the success rate.
Yeah, this one always gets me. Studies using high-speed cameras have shown they catch about 95% of the insects they chase.
95%? That's almost perfect. Compare that to, like, a lion, which might succeed maybe 25–30% of the time.
Exactly. It's an astonishingly high success rate. If a dragonfly targets a mosquito or a fly, that insect's chances are practically zero. They calculate interception trajectories like guided missiles.
And their eyes must play a huge role, too. Those giant compound eyes.
Absolutely. They provide nearly 360-degree vision. Each eye has tens of thousands of lenses, ommatidia, giving them incredible motion detection and the ability to see things much faster than we can, like seeing the world in slow motion.
Yeah.
Helps them track erratic prey.
So they emerge, harden their wings, and become these ultimate flying predators. But didn't we say the adult stage is short?
That's the great paradox. All that perfection, all that capability built over years. And the adult stage itself is fleeting. While the nymph lived for years, the adult dragonfly typically lives for only a few weeks, maybe a few months, at the absolute most for some larger species.
Weeks. After 5 years of preparation.
It's a stark contrast, isn't it? It really underscores the biological strategy. Long, slow development for a short, intense final act.
And what's the purpose of that short adult life then? Just flying around catching bugs?
Catching bugs is mainly to fuel the real purpose. The sources are clear. The singular adult focus is reproduction, finding mates, competing for territories, mating, and for the females, laying those eggs to start the whole cycle over again. That's the mission.
So the incredible flight, the 95% hunt success, it's all geared towards maximizing the chances of mating and laying eggs in that short window.
Precisely. It's a high-energy, high-stakes game concentrated into a few weeks. The adult dragonfly is essentially a highly mobile, extremely efficient reproductive machine powered by the energy stored up during those long years underwater.
Wow. Okay, so we've seen the tough egg, the long-lived underwater hunter nymph, and this short-lived aerial acrobat adult. Let's try and pull it all together now. What does this amazing cycle mean in the bigger picture?
All right, let's zoom out. Section 4. Ecological significance and evolutionary success. One of the most important roles dragonflies play, especially the nymphs, links back to their habitat needs. They function as key bioindicators.
Bioindicators, meaning their presence or absence tells us something important about the environment.
Exactly. Because the nymphs spend so long underwater, up to 5 years, remember, and have specific requirements, they give us a long-term reading of water quality.
What specific requirements?
The big one is clean water. Dragonfly nymphs need clean water to survive. They are very sensitive to pollution. They need high levels of dissolved oxygen in the water. Pollution, like fertilizer runoff, can cause algal blooms that use up oxygen, making it hard for nymphs to breathe.
Okay, so low oxygen is bad for them. What else?
They're also sensitive to chemical pollutants, pesticides, heavy metals, things that wash into streams and ponds and accumulate in the sediment where the nymphs live and hunt. If those pollutants reach certain levels, the nymphs just can't survive that multi-year development.
So if you see lots of different kinds of dragonflies flying around a pond,
It's generally a very good sign. It tells you that the water has likely been clean enough, with enough oxygen, and relatively free from major chemical contamination, not just today, but consistently over the past few years, to allow those nymphs to complete their development.
so they're like living water quality sensors. That's pretty cool.
It really is. They are vital sentinels for freshwater health. Their presence signals a healthy ecosystem capable of supporting complex life over the long term.
And this success, this sensitivity yet resilience, ties back to that incredible evolutionary history, that 300 million year track record.
Absolutely. We have to keep coming back to that number. The sources emphasize this evolutionary insight. Dragonflies have barely changed their fundamental design in hundreds of millions of years.
Why? Why didn't they need to change?
Because the design was just so effective from early on, particularly that flight mechanism, the 4 independent wings, the powerful muscles. They achieved aerial mastery very early in evolutionary history when flight was still a novelty.
They cracked the code for flying and hunting in the air so well that evolution basically said, okay, good enough.
That seems to be the case. That design has allowed them to survive and thrive through massive environmental changes that wiped out countless other species. It's a testament to the robustness of their solution.
So if we put all 3 stages together,
You see the complete picture. The tough, sometimes dormant egg gets them started safely. The long predatory nymph stage allows for massive growth, energy storage, and plays a key ecological role underwater. And the short, hyper-efficient adult stage maximizes reproduction and dispersal using that perfected flight system.
each stage perfectly adapted to its role, its environment, covering all the bases: water, air, survival, reproduction.
It's an incredibly integrated and successful life strategy. The long-hitting preparation enabling the brief, spectacular execution.
Okay, let's try to sum up the key points from this deep dive into the dragonfly. We've gone from that tiny, tough egg through years as an underwater nymph to the final, fleeting weeks as an aerial master.
I think the 2 absolute must-remember points for you, the listener, are about time and place. First, remember the sheer amount of time. The vast majority of a dragonfly's life, often years, is spent underwater as a nymph. The flying adult is just the final chapter.
Right, the underwater part is the main event in terms of duration.
And second, because those nymphs need specific conditions for so long, their presence is a really reliable indicator of clean water. If you see dragonflies, it's generally a sign that the aquatic environment they came from is healthy. They're nature's water quality inspectors.
Essential ecological markers. Okay, and as always, we want to leave you with something to think about, a provocative thought that arises from the sources.
Given everything we've discussed, if the adult dragonfly, the one we see and admire, only lives for a few weeks with the sole mission of reproducing, and the nymph stage lasts for years, growing, hunting, dominating its underwater world, does that maybe shift how we think about the real dragonfly?
You mean, is the main dragonfly the creature of the air that we recognize, or is it actually that long-lived, hidden creature of the deep? The nymph seems to be the core of its survival strategy, the part that has endured for 300 million years. The adult is almost like the delivery mechanism for the next generation of nymphs.
It's a fascinating perspective, isn't it? Does that long hidden preparation phase define the organism more than the brief visible culmination? Think about that model. Long, often unseen development leading to a short, intense period of function or display. Where else do we see that pattern? Maybe in technology or careers or even other life forms. What constitutes the real essence?
Something definitely worth mulling over next time you see a dragonfly darting past. A creature much older and perhaps stranger than we usually imagine.
A true ancient marvel.
Absolutely. Well, that brings us to the end of this deep dive. Huge thanks for sharing your sources with us and allowing us to explore the incredible life of the dragonfly.
Until next time.